Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. And this will be chapter 4.6. We will be dealing with moment of a couple in this recording. And yeah, inshallah we will begin. Bismillahirrahmanirrahim. Rabbi zidni warzuqni fahma. Allahumma aftah lana hikmataka wa anshur alana min khazaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, Bismillah. So this is 4.6 moment of a couple. Just to refresh, hopefully you still remember what we have covered in chapter 4. And basically we have started with moment about and at a point. Right, we have covered that one, moment of a point. Okay, the zooming, I'm not sure what's happening with my camera. The zooming have been having issues lately. Anyway, so moment about a point. So hopefully you still remember. In terms of scalar, it's m equal to f times d. Vector will be m equal to r cross f. Right? And this r cross f is basically from, if you were to visualize it, is from a point to the force. R will be from the point to the force, right? So that's moment about a point. And then we have covered also moment about an axis, right? So in terms of scalar, the equation is always the same. In terms of vector, it will be u dot r cross f, right? And of course, this u is for the axis, and this is r is from axis to the force, right? And f is obviously the force, right? So that's what we have covered before, and for this one we will add another one. We will learn a new thing, which is moment of a couple, right? Right, so before we go into the calculation, etc., perhaps we should know first what is a couple, right? And what is so special about a couple that it deserves a special mention and it becomes a subtopic of itself, right? So let's go to the application. So I will skip some of the application discussion. We will straightway go into the concept. So what is a couple? Moment of a couple, right? So a couple is defined as two parallel forces with the same magnitude but opposite in direction, separated by perpendicular distance d. So basically, if you have two forces that is parallel to each other in the opposite direction with the same magnitude of forces, and of course when it's parallel, you will have the perpendicular distance to both. So this is by definition a couple, right? So just to refresh, if it's not parallel, right? If it's not parallel, that's confirmed not a couple, right? If it's on the same direction, right? It's not the opposite. It's the same direction like this. This is not a couple also, right? It has to be opposing direction. And if the magnitude is not the same, then also it is not a couple, right? And yeah, so that's basically the characteristics. I'm not sure what is happening, right? Because the zooming is problematic right now. And is this lens broken or something? Okay, Bismillah. Hopefully the lens and the zooming is okay. And I hope that anyway, inshallah, let's hope for the best, right? If you cannot even see because it's blurry because of the zooming is off, then this video will be to waste, right? Anyway, so basically we have defined what is a couple, right? Just to refresh, it has to be parallel, opposite direction, same magnitude, right? That's a couple. And we will see what is the importance of this one, right? But of course, in terms of the equation, this is what we are learning today. So it is m equal to f times d. Of course, the difference here is this distance is just from the point to the force, and it should be perpendicular to the force. This distance is perpendicular to both the axis and also the force, and obviously this one is the distance perpendicular to both of the force, right? And for this one, M equal to R cross F, and we will discuss about this a bit later, right? Because what we have is only just two forces, and so we have to discuss what is R and which one is F, because we have two F, right? So let's discuss some examples to illustrate what is so special about couple, right? Let's imagine several scenarios, right? So one scenario is like this. One scenario, okay, this is the same pole or same structure, let's say. And let's imagine this couple, right, when we have something like this, where we have the same value, let's say 10 Newton at a distance of 1 meter, right? So hopefully you can see that one. So we consider that one, and we put it at the different places. For example, here we put this couple here, so 10 Newton, obviously this is 1 meter, 1 meter, 1 meter in a 3 meter total, right? And this one, for this one, we just put it here. Meaning it's exactly the same couple, we just shift it downwards here, and we shift it also downwards here. Right? So let's imagine this is point O, point A, point B, point C. Right? Let's imagine that. So if I have to calculate, right, and I think one thing is obvious is that if you are to calculate summation of forces, it will always be 0, right, for these two forces, for the couple, right, because it is the same value opposite to each other. This one is the same, this one is the same, so that's straightforward. But let's consider the moment, right? If you calculate summation of moment about point O here, right, and if I take, let's say, clockwise as positive, let us take clockwise as positive. So if moment about point O for this 10 Newton to the right, it will be clockwise. So 10 Newton times the distance now is 3, right? 3 meter, right? And then this one is the opposite way, the counterclockwise, so minus 10, a distance of 2. And then you can calculate, this will be 10 Newton meter, right? Where 30 minus 20 is 10 Newton meter. Now, if you calculate summation of moment about point A, let's say we take clockwise as positive also. So about point A, so this one is clockwise 10 with a distance of 2. And then this is counterclockwise, so minus 10, distance of 1. You'll get another 10 Newton meter. But if you do the same about summation of moment about point B, you can try it, right? Because this one is going to the point B, it doesn't produce any moment. This one is clockwise, so you'll still get 10 Newton meter. That's interesting, where this couple actually produce the same exact amount of moment or value of moment regardless of any point along the structure, right? So the same couple, but it's basically two forces, which is a couple. It always produces the same moment about any point anywhere, right? Now what about this one? So let's just prove this. Is this okay, right? So it's about point O, point A, point B, and point C, say, right? If you listen to summation of moment about point O, basically you have, if you still take clockwise as positive, so you have 10 times 2 there, minus 10 times 1, you get 10 Newton meter. And you repeat again about point A, B, C, and here, if you want to try, you will see the same, right? About point O, it's still 10 times 1 is 10 Newton meter. So that's what's special about couple, is where basically the effect is always the same. In terms of the summation of force, it's always equal to 0. and in terms of summation of moment, it's always equal to, and this is the thing, right? It's always equal to force times distance. You can see here, this is the couple. If whatever the structure, whatever it is, you just focus on the couple. F times D is basically just 10 times 1 in this case, become 10 Newton meter, and you should be able to tell this is clockwise. This is always the same, right? So that is the thing with couple. The effect is always the same. So as a result, it can be placed anywhere. The effect to the structure will always be the same, right? So that's why in the slide you see that they say couple moment is actually a free vector, because regardless of where you shift it, it's basically just this effect. In this case, basically, where it's 10 with a distance of 1, right? So it will always have this effect, which is clockwise rotation or moment with this value, regardless about any point or regardless of where the moment is placed, right? So that's the thing, right? Hopefully you understand that why couple is special, right? Okay, so we have the example 1, scalar approach, right? So if you see the slide, you have the example. So let's try that one. Okay, by the way, we have shown here the scalar calculation, right? We will show how to use vector and still using this one, right? But okay, this one is just to prove the point, right? But we will focus on this one here. Right. Now, if you can imagine that moment about point here is basically when you have a point and they have a force, R is from there and F is there, right? And if you understand your right hand rule, it's basically R plus F, you get your moment, right? With your thumb going in, which means it's clockwise, right? Now, if you have two forces, let's just see it like this. If you take, because there's two forces, so R is from one point on one of the force into another point in the other force, right? So let's say just, if I take this as my R, then if you understand the concept like this, like R and then cross F, so it should be R and then cross F. So this is the F that I have to consider for R cross F. If I use a different one, for example, if I use R going down, my F is this one, right? So it's basically R and then cross F, right? So that F, it should be at the end of R, right? So hopefully you understand this one, right? So if R is going here, then F is this one. If R going here, F is this one, right? And the answer should be the same. Alright, so and in this case, in this case it's quite obvious, right? So if you have 10 Newton and 1 meter, right? So if I consider R is going straight up, so R is, if I consider this is X and Y, so R is basically 0I plus 1G. And obviously this 10N is just plus 10I Newton. Right? So if I do R cross F, it will be I J K 0 1 0 10 0 0. Right? If you solve this one for I, you get 0 minus 0. For minus J, you get 0 minus 0. Then plus K, you get 0 minus 10. So in the end, you'll get minus 10 K Newton meter, right? And that is exactly what we have calculated just now, which is positive clockwise of 10 Newton meter. So this negative k meaning that your thumb going into the negative k, and then the rotation is clockwise, as we have discussed before, which I have already erased. The answer is 10 Newton meter clockwise. So the answer should be the same anyway. Right, so that's an illustration of how to apply this equation. Alright, so let's go into this problem there. So basically, okay, you can refer to the slide, and I'm just going to straightway do what is the solution, right? So if you see the slide, you should be able to notice that there are two couples, right? Let's read the question first. Two couples act on the beam with the geometry shown. Find the magnitude of F. So that resultant couple moment is 1.5 kilonewton meter clockwise. So first, understanding the question, what is it? You have two couple, but one of the couple you do not know the force. If you see the diagram, it's just F. And then it says the magnitude, you need to find the magnitude of F so that the resultant couple moment is 1.5 kilonewton meter clockwise. So we know for sure already the summation of moment, couple moment, clockwise to be 1.5 kilonewton meter. Right, so that's the answer. And then we need to know what is F, right? So you should be able to isolate the two couples, right? So we have one couple which is basically like this, 2 kilonewton, which is the distance of 0.3 meter, right? And you take out also the F, right? So we have F and F with the distance of 0.9 meter, right? So that's the two couple. So right now, if we already know the two couple, and the net result of this should be this one. So basically 1.5 kilonewton is just summation of this F times D plus this F times D, right? And if you take clockwise as positive, this one is counterclockwise. Hopefully you can see it's counterclockwise. So it will be negative 2 kilonewton times the distance of 0.3. And then this one is clockwise, right? Clockwise, so plus F times 0.9. Once you have this one, is an equation that you can solve straight away, right? Yeah. So by this you can solve what is F, and it should be the same as the slide. So I'm just showing you the steps. You should be able to follow and see what is the result, and it should be the same as the slides there, right? Hopefully that is clear, right? That is one way the question can be asked, where it is asking, it doesn't give you the force, it gives you the resultant moment, and you have to back calculate to get what is the force, right? Alright, so that question is down. Alright, now we have the example number 2, we have vector approach, right? 450 Newton force couple acting on the pipe assembly. So the diagram is given, refer to the slide. Find the couple moment in Cartesian vector notation, right? So we need to find what is the couple moment in terms of ijk, basically what it means. So hopefully you can identify the couple and just take out the couple. As I mentioned, we just are interested at the important points, only important information. So whatever the shape of the pipe, etc., that's not important. What is important is the point and the force, right? For this kind of question. So basically we have point B and point A, right? And then you have the force here and the force here. And it is already given as 450 Newton, 450 Newton, right? And the angle is given there, right? But because it's drawn in 3D, I will just draw it like this, and I think you can follow, right? So what do you need to do? Now you know that you can calculate using M equal to R cross F. We want to find the moment in Cartesian vector notation. Anyway, So if I use, okay, if I use R is RBA, then the force should be the force at A, right, in terms of R cross F, because that's the cross product, right? If I use the opposite way for RAB, then force should be at B. Right? Hopefully by now you have understood that already, right? So actually this one, the solution is quite simple. It's just to calculate, right? Because if you get the idea, it's just to calculate, because all the calculations are from the previous chapter, basically how to determine the coordinate and how to determine the vector of the force when you have the angle given there, right? So do I need to explain this in detail? I think you can follow the slide, right? Because this one, basically the idea is you just, if this is the R that you will get, you will use, this one will be the F, so you just translate this or transform this into Cartesian vector form. In this case, it's basically, okay, let's just try. So 450 in terms of the X component is 0, so 0i, and then Y component is negative side, so negative 450, the triangle is 4/5, and then plus, so this is J, so plus 450, 3/5 K, right? So that will be the vector for this particular one. This one will be the opposite, obviously, right? So you have to decide from the beginning which one you want to use. So if I just use RBA, and then that's the force. So RBA will be minus 0.4 I plus 0J plus 0K, right? It's just straight away in the along x-axis but in the opposite direction. So if you have already obtained these two, so you just plug in here, right? So you'll get some M equal to R cross F equal to I J K, and then the R component, which is minus 0.400, and then the F component, which is 0 minus 450, 4/5, 450, 3/5, and you can calculate that one until the end, right? So that's how you address or approach question like this, right? Just identify what is the couple. In this case, it's quite straightforward because there's only two force, which is one couple, and then just decide from R that you want to use in this equation is from which force to which force. Then the force that you will take here is the second force, right? So, and the rest is just mathematical calculation, right? So hopefully you understand by now what's going on and how to apply the equation. Let us see for further example. Is there any other example? Alright, here is group problem solving. If you can see the slide, it gives you a 2D problem with two pairs of couple, right? So let us attempt that one. Right. So basically, if you see the problem, it's something like this, right? Where you have two forces here and another two forces here, right? Okay, so the zooming is still problematic. Hopefully it's okay. So it's something like that, right? Now, I'm just going through without going to the detail of the. Okay, we'll go into detail because otherwise I'm not sure if anyone will follow. Okay, 30 kilonewton till the kilonewton, and the angle is 3, 4, 5. Oh, 3, 4, 5. And then this one is 15 kilonewton, 15 kilonewton with the angle of, this one is 30 degrees, this one is 30 degrees, right? So that's the problem. So how to solve? The question says what is the resultant couple moment, right? How to solve this one? So again, you just identify and isolate the couples, right? So here we have one couple and here is one couple, right? However, to get the perpendicular distance, if you maintain it in that way, it will be difficult, right? So normally what we do is, again, we will resolve into x and y component, and then all the distance will be much more straightforward, right? So that is what we will do. So in this case, it will be something like this. So this is xy component, xy component, xy component, xy component, and obviously this is actually should overlap because it's on the same line. Right, so with that, you can see that you will end up with 4 different couples, right? Not really, but if you see this one here and this one here is actually just something like this, right? It just cancel each other without producing. This is not a couple in the sense that it doesn't have any distance between it. But you have here this pair, right, which is 34/5 or 34/5, and the distance, which is this one. Okay, the question it gives you 2 meters. I didn't draw it here, but this is the distance of 2 meters. Now, here the up and down is just something like that. It cancels each other, no moment. But this force and this force will produce moment, right? This is a couple. Basically, this is 15 cos 30. Obviously, the same here, 15 cos 30. How do you get that? This is 15 cos 30. And the distance here is also given as 2 meters. Right, so that is what the question gives. I didn't write it there, but it's 2 meters that distance. So how to get the resultant moment is simply just add of the moment of each. Right? So summation of moment is basically summation of F times D. And if you take clockwise as positive, let's take clockwise as positive. So in this case, this is 0. Right? This one will be clockwise, right? As you can see, clockwise. So force times distance, so 34/5 times the distance of 2 meters. This one doesn't produce any moment. This one is still clockwise also, so plus 15 cos 30 with the distance of 2. Right, and then you can calculate, you'll get the answer straight away, right? So hopefully by now you should realize that, oh, okay, it's not that difficult, right? It's just isolate the couple. You know which equation you want to use, apply, and for this is calculation, you add them up, you get the resultant moment, resultant couple moment. Right, so hopefully you're still following. So the answer is as given in the slide, right? Alright, so another group problem solving. Here you will have a 3D problem with a wrench there, right? So alright, it will be quite interesting because I don't think I can draw the 3D accurately here for you to see. So please refer to the slide. So basically what you have is simply you just have one force here and one force here at a different point, right? And it doesn't have a label of points, so I cannot put A or B or C, right? But if you see the problem, it is the force, the 2 forces given, right? And then so the idea is the same, as long as you can get, okay, let me see, say is R from here to here, then F is this one, and then I just plug in into the R cross F, I will get the answer, right? So the concept is simple. Please do try this problem because I think the issue here is some student might not even realize that the distance, the x distance for this one and this one is different, so that when you get the R, you will have some value for the x coordinate or x component, right? So many students miss that because from visually it doesn't seem to, it's almost seems similar, the length, but if you see the number is not, right? So make sure you try this kind of question to see if there's any mistake that you tend to make, so that you will never make it and you will check for it in your final exam or in your midterm. Right, so the rest is just a repetition of what steps that we have covered before. Right, so is there any other question? So that's it. So it's not that much of a new concept. It's just understanding the concept, both in scalar and vector, and try some questions so that you are able to apply this to all type of questions, right? And of course, if you need to watch the recording for when I cover in the class for previous exam questions. You can do so. Hopefully that helps also to see what type of different question that can come up to test your ability to calculate this one, because sometimes the question is have some trick question or something differently presented, so that if you do not understand or if you do not realize about certain things, you might make some mistakes. So please watch that also. And with that, I think that's it for couple. Yeah, an overview conclusion. So if you have any problem where you have a lot of couple, right? For example, in the structure, you have couple here, couple here, couple here, and couples there. As we have shown, do not be panicked, right? Do not feel like overwhelmed when you see too many forces and too many couple, etc., etc. Right? So because some students tend to get panic, right? Oh my goodness, so many couple, tak takut neraka ke, tak takut dosa ke apa, banyaknya couple. No, do not be intimidated by anything. Just look at the bigger picture, isolate, okay, this is one couple, this is another couple, this is another couple, solve one by one, insyaAllah all will be solved. Gejala sosial semua insyaAllah akan dapat selesai, insyaAllah. Right, so, and also, if you have the forces in angles, sometimes, especially in 2D, it's best to resolve into x and y so that the distance will be easy to calculate, right? So that's another thing. For vector, you don't have that issue because it's simply r cross f, and all of these already have the x component, y component, and z component, and it will calculate itself in the matrix, so you do not need to worry about that one, about the distance, right? Because r, as long as you know the two coordinate, you can just calculate, right? Inshallah. Wallahu alam. So that's for this one. We will see you for the remaining of chapter 4 inshallah. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.